Hi everyone. This is a short class basically explaining the case and giving you some instructions for how to perform the analysis that I wanted you to do based on this case. We will use Excel, basically trying to emulate a real decision that we make, for example, at the university, of emailing students about a free tutoring session and try to forecasting how many will sign up. Basically, the idea is that we have two discrete random variables, which is the first one is a single student decision of signing up or not signing up to this email. And we have the second random variable that we're going to analyze, which is the total signups across all any students that may sign or not, may sign for the tutoring session. Okay. Um, in the middle of our analysis, I'm gonna try to show you how permutations and combinations fit in this context here. Okay, so let's dive right in. So imagine this the following: we have a planned uh, tutoring session next week, and we have to see how many students will sign up for our session because if we have just few students signing up, we have a lot of underused resources. Um, we don't know how many seats we should provide. We don't know for how many time we should run the session. If we're gonna provide some lunch or some snacks, depending on the time of the session, we don't know for how many people we should provide food, for example. This is a very common type of decision when you are running whatever type of event and you have uh, previous signups or RSVPs and stuff like that. Okay. In this case, probability will help us to forecast what are the likely outcomes in terms of participation and then plan the event. Okay. For one specific student, the outcome is either sign up or not. Okay. So we can think about that being the sign up being a success for us, which is can be translated in the number one, for example. So if the students say, yes, I will participate, instead of recording this information, we can record just the number one, which means, yeah, this specific student will participate. The failure in this case is can be represented, for example, of for the number zero, which is basically saying, yeah, the student will not participate, and we can record that information as zero. Okay. Um, those are zero and one then are the values uh, of our variable student signing up for the event. And basically, those types of answers, which is a bivariate one, which is zero and one, they do follow what we call Bernoulli. They are a Bernoulli random variable. Okay, Bernoulli type of random variable because basically what that means is you have the probability p associated to one and you have the probability 1 minus p associated to 0, which is the failure. Note that that's basically the complement probability of 1. Okay? Um, okay. So one specific and interesting assumption that we need to think about this type of variable is uh, all the individuals um, that are trying to sign up or rejecting to sign up in our email, they have equal probability of sign up or not, which is half. So it meaning each value assigned to our random variable has 50% probability of being a yes or a no, or a success or a failure. And some other characteristics that we can analyze about this variable is that we can calculate the expected value of the random variable b, which is the signups. This symbol can show up this in this way or with a Greek letter, which is similar to this E right here, but it basically means the expected value of P of the probability. Uh, and we can also calculate the variance of B. In this case, the variance of B, which is the signups of each student, is given for us to the probability times 1 minus the probability. Okay? And this is what theory says to us that we should expect in terms of variance without even knowing the distribution if we know what is P. Okay? Um, good. So the second thing that we want to analyze is basically the totals or the summation of each individual student. And this summation of each individual student should follow what we call binomial probability distribution or binomial mass function. Both are the same thing, and you should understand them in the same way when you see PMF or PDF. Okay, they are both the same, exactly the same thing. I would highly recommend you to read the book item 4.2, and you're gonna have a better description about binomial distributions there. Okay, what a distribution is basically a summation of all the probabilities that we have for all the students that sign up. Okay. In this case, the binomial distribution has some assumptions associated to it. The first assumption is that we have independent events, and independent events means each student are independent. Each student sign up decision is independent in itself, which means we are assuming out that individuals don't necessarily talk with each other to make any of those decisions. For example, we can consider a case where we have two students and they are friends and they made plans to go out in the next week, and their plans overlap with the same time that we are planning to run the session. Because of that, they may not sign up to our session. But is this decision really independent in this case? Independence, remember, this concept comes from probability and means that the decision of one individual will not affect the decision of other individual. Okay. By assumption, we are assuming out that uh, they are independent. Each one will sign up, and we don't have any interference of one individual in another's decision. Um, this probability distribution, which is the binomial one, follows as well um, two parameters. Okay, and the representation that we can do for that is basically the distribution, the binomial distribution X has average or expected values N and variance P. Okay? Um, this is the general notation. We could actually write expected values like this and variance like this. Okay? It's fine as well. Um, I just kept this notation because probably in the book you're gonna see a similar notation like this one. Okay, another important assumption that we have here is that the probability mass function or the probability distribution function is given by this formula. Okay, and this formula basically gives us a theoretical way to understand how the summation of the students' decisions will shape. Okay, uh, and basically, I'm gonna explain this formula in more detail when we are in class, and when I'm gonna show you this formula in Excel. But basically, note that the first part of this formula is actually a combination. Okay, and here is how combination starts to play a role in distribution functions, combinations and permutations. We're gonna see other types of distributions where permutation also plays a role. Okay, what basically means is that if we can feed all those parameters, which is the total number of observations, the actual values that we have in the distribution, and the probability associated to it, uh, we necessarily can know what is the probability distribution of these values, and that could inform us in terms of deciding how many people are likely to come or to sign up to our event. Okay? I think the most important parameter here is the probability associated to each individual to sign up. Okay? How we know that? We know that by previous events, for example. Okay? That's how we define that. Once we collected data once for one event, in the second event, we know on average that the probability of signing up is 30% or 20%. Okay. Um, okay, great. So in this case, we have a fixed number of trials, which means each student is one specific trial in our experiment. And we have just two outcomes, which is sign up and to go and deciding going to the session and not signing up. Okay. We denote that probability of success as P, as I already told you, and we have this independence assumption, which we can discuss whether it's an effective assumption or not, or if that's on average an approximation of reality. Uh, this will give us then a binomial distribution function, which allows us to track the total number of students likely to sign up and then forecast how many seats we need to have or what is the size of the room that we need to have to our section. Okay? So this is the general explanation for the problem. What I want you to do is basically uh, go through each one of the sheets here. I'm going to show you some of them. Uh, and basically use the information that's already calculated so you don't need to do any types of calculations on your own unless you want to replicate what I'm doing. And I'm going to provide another spreadsheet for you to do that. Uh, and basically learn a little bit more about Excel and doing that, and also learn about the process of the calculations that are happening here. Again, I'm gonna keep explaining and using this spreadsheet in next classes. And for the exercise, what I want you to do is basically explore the spreadsheet, use the information that's already calculated here, and this is explanation that I provided to you to do an analysis and then answer some questions that are assigned here, and those questions will be answered in the form on eCampus. Okay, so basically, what I did here is a small simulation. Uh, so I create a parameter and I said the probability of a student to sign up is about 20% by our anecdotal knowledge of previous events. Then I show you what is the probability distribution of signing up and what is the CDF, which is the cumulative probability function uh, for this case. Remember, this cumulative function is derived basically in the same way that we did from the cumulative um, relative tables that we did before. So we basically sum uh, the num the probability associated to the event in the previous row in the second row. Okay. In this case, it's a very simple one because we just have two possible outcomes, which is signing up or not signing up, or success and failure. And as you can see here, for example, the probability of signing up is the probability of not signing up plus what is the probability of signing up plus 1 minus the probability of not signing up. Okay, so this is the cumulative version for this specific case. Um, how I calculate the probabilities here, which is the probability associated to each uh, potential outcome that I have. Uh, Basically, the probability of failure is 1 minus the probability that I have that I know that they have to sign up, and 1 is the probability they actually have to sign up. Okay. Um, Here I show you how I calculate the expected value in this case. Is basically same as the probability value. Uh, how I calculate the variation, which is basically using the formula, which is P times 1 minus P. So this is let's call this the theoretical variance, and this is the standard deviation. Okay. The standard deviation, we know that is the square root of that. So is basically what I'm doing here, the square root of the previous value, which is the variance. Okay. Okay, so I have done all of that basically just having one piece of information, which is this probability, which came to my knowledge. Um, that's the probability associated by previous events, for example. And with that information and the theoretical information that I have about the distribution, I was able to perform what is the expectation, what is the variation, what is the standard deviation, what is the probability distribution, and what is the cumulative distribution function. Okay? What I did then is that I created a simulation, I created a sample, and this sample has about 1,000 rows. And what I did then is that I calculated the mean, variance, and standard deviation from this sample. One of the things that I'm asking for you to do is to compare each one of these ones with this one. Okay? And note that this case right here is based on a simulation of students signing up or not. It's kind of if we had all the results of our emails back and if we tabulate them, then we have a by student answer. And what I did here is basically I calculated the expected value, which is this one of B. Here's the variance of B, and here is the standard deviation. Okay? I want you to compare and contrast those two different ways to calculating and how they are similar or different. Okay? What you can do as well is try to do the same simulation exercise by yourself and see the results. Okay? What is important here? If you understand how this theoretical way is calculated, every time that you face and you understand that's a binomial distribution that you are dealing with, you don't need necessarily to collect all the data to know what's going to be the variance, the standard deviation, and the expected value. Okay? Especially if you have some sense of the probability P um, in the case that you are dealing with. Okay? Why this is important to us? So each individual decision here is what we call a Bernoulli event. And this variable here, this random variable of each individual student deciding between signing or not is a Bernoulli, follow a Bernoulli type of event. Okay. The summation of all the students as I'm presenting here and here, they follow a binomial distribution function as I'm presenting here with a probability associated to each one of the outcomes. So moving forward, I showed you that the binomial distribution has some formula, which is this formula right here. And basically, this formula gives us what is the probability associated to each event, given we know some parameters. Which are the parameters that we need to know? How many students? What is the size of our N? Okay. And what is P, which is the probability associated with each student to sign up in our event. Okay. What I did here is basically I calculated uh, the probability mass function using the manual way, which is the formula that I presented to you, and using the Excel automated way, which is this formula right here, binom.dist, for each one of the 30 students. Okay? And basically, you can give a double click in the cells and you can see how the formula is performed, but basically is using those two parameters. The result, this A7 formula is collecting what is the observation, the number of the observation that we are looking at in each one of the cases. Uh, and we are signing here that's not a cumulative function. If we sign false, that's saying we are dealing with a PMF, which is a probability distribution function, and not a CDF. Okay, if we do that true, this argument true, that's going to be calculated as a CDF as in the next column. Note, here is the true. Okay. Which is the cumulative one, which means basically this second line here is the summation of the first line plus this second probability associated with the second individual in our sample. Okay. Um, what is the exercise here? So I did that with the Excel formula basically and manually. Okay. Here is the manual formula, the theoretical one. What I wanted you to do is compare each one of those values here. And here is the difference between them. And you can tell how close or far they are. And I wanted you to explain why is that happening. Okay. So here you have basically the graphs is a line graph from the two of them, and you can also compare it visually and say how similar or not they are. Okay. Um, the other exercise associated to it is basically uh, we have here some we have here some calculation as well, similar to the previous table associated to this situation right here. Okay, so basically you can see we are using the parameters that we set up in the beginning. And basically it's the theoretical calculations and how we calculate expected value variance and standard deviation now for the binomial distribution. Okay. In the slides, you're going to find out the formulas for how to do this. And this is the theoretical way, as similar as we did here in the previous table. Uh, what I did then is that I created a simulation, okay, with a lot of draws as well. And what I did is I calculated again this simulated mean variance and standard deviation based on the draws of the data that I have. Okay. I want you to do the similar exercise of comparing both of them again and understanding why they are similar or not. Okay. And when I mean similar, obviously you cannot think about, I mean, one decimal point or two decimal points of difference. That's not enough different. If we round everything to uh we round everything to have numbers without decimals, uh we should have the same number. Okay, so I'm not asking you to analyze the decimal differences. I think that's the point. Okay. Um, for now, we're gonna skip this one right here. I mean, we don't need to look at it very deeply because I think I'm not asking anything related to this table, and I'm gonna explain this one in class. But you can also look at it. I'm doing the same process that we did here, but now uh, doing just a Bernoulli formatted exercise. Here I did the draws of the possibility of sign-ups and having a positive number of possibilities, which is the summation of this one. So the summation of the Bernoulli ones here. In this case, I'm doing each one individually, and then we can also calculate the results and see if they follow the same pattern. Okay, but we're gonna do that in class, and I'm gonna explain this a little bit better in class. I'm gonna move to the next table that we have, which is basically I'm showing in more detail here how you calculate the probability or the combination and the permutation, and also how can you use combination and permutation to do the calculations of the binomial distribution function as I showed you. Okay, so basically you have some cases here, and I'm also showing you that you can calculate uh, combinations and permutations not using the Excel formula as we are using here, which is combine parentheses, and you state the n number, which is the number of observations, and the what is the size of the small group that you want to combine by. Or, for example, in the case of the permutation, which is basically the same, the number of observations and the size of the group that you wanted to combine by. But you can use the function fact, which is basically factorial, to do the calculation using the Excel formulas that we saw in class on Tuesday. Okay. Um, so here's what is the connection that we have between, uh, for example, in this case, between combination and the binomial distribution. The part of the binomial distribution is actually formed by a combination process. Okay. Uh, so this is why we study permutation and combination right after distributions, because some of the distributions, part of them is formed, the formula is formed by combinations or permutations. Okay, the assignment. Okay, the idea here is basically one, go read the book. Two, watch the video. Three, look at the slides and then answer those questions. Those are the same questions that are in the form. So you don't need to submit the spreadsheet. You don't need to do anything with the spreadsheet unless you want to do a replication to understand better what's going on. And you also don't need to submit your replication. You just need to look at the tables here, perform the analysis that I sort of guide you through. The questions are pretty much similar to everything that I have explained in the video. And I want you to go there and answer the form with your own words for each question. Don't leave any one of the questions empty. If you have any problems in understanding something, email me or send me a note through eCampus that I can help you through the process. Okay? But they are in general very simple questions, and they are questions just to check if you read the book and understand what's going on in the slides. And that's gonna make our life much easier when I come back and I go through step by step on the table, and you can understand that more clearly for sure when we do together in class um, the exercise in the next week. Okay. Um, in the end, I wanted you to also provide the last question is provide a brief answer and recommend what is the size of the room that we should expect in those cases, given the information that we have and we know how to, what is the expected sign up in each one in the case that we are looking for the session that we are planning. Okay. So basically, go through each step of the spreadsheet. So read through this one, go to this one. The yellow cells are yellow on purpose, so they are the ones that you should stick with for now. Uh, except for this one right here. So this one right here, I'm gonna explain in class, but those ones here, you can go through and look them through. They are formulas and they are important calculations that you need to learn. I think that's all. If you have any questions, please email me and or send me a note through eCampus. I'm gonna be happy to take it. See you in class next week. Bye bye.